shut-off valves. Mitigation strategies. What does that mean to you? Three main mitigations, okay? One, the size of the room volume, or the cubic feet. Air circulation. Are we going to have to turn on the evaporator fans and move that concentration around to make it less concentrated so it's less possibility for flammability? Or are we going to need to bring in mechanical ventilation, either bringing air in or taking out if the room is too small? You need to ask yourself, is my releasable charge large enough where I need additional safety controls such as air circulation and or ventilation? And then if the charge size is large enough to need additional mitigations, other options could possibly such as smaller circuits. So if it exceeds where we need more than mechanical ventilation, we can look at smaller circuit sizes, smaller lines, sizes, lengths, and what have you. Critical for walk-in coolers, compressor units, and condensing units. The cases, I wanted to point this out. I actually put this in caps earlier this morning and underlined it. Cases are always the multiplier of the LFL, 8 times doors and drawers and 13 times open case. All right. So let's look at this walk-in cooler, if you will. This is a great image here to walk through what it means as far as releasable charge. Okay. So you can see our charge is going in this walk-in cooler. And we're leaving here with this check valve in place. So this is your isolation valves, if you will. We have a refrigerant sensor. We have the evaporator coils like you see in any walk-in cooler that we've been in before, all right? This just happens to be a 3-fan operation. So the scenario is this. The refrigerant leak occurs. Sensor picks that up. Okay, the mitigation is activated. If it's just calling for a movement of the air, if it needs that, it could be the volume and you don't need this to kick on, but whatever that strategy is, this will activate, okay? And then the releasable charge is in between the valves. So if we get into a leak detection senses it, it's going to go into mitigation strategies. That could be just the isolation or the cubic feet of in the box itself, or it could be the fans come in on lesser charges on what would be your doors and drawers, and then you're going to have to bring in, or the larger one where you have to bring mechanical ventilation in. What it does is the solenoid valve will activate, will shut it down. This will check valve, will stop anything that's beyond this. This all on this side will all be pumped out. So the most of the charge is going to be pumped out back to the condensing unit or the compressor. Okay, this is what they're talking about in releasable charge. And depending on the application is how much. The larger the system, walk-in coolers, supermarkets, what have you, the more your charge you're going to be allowed in this releasable charge. Okay, so if they sense a leak up here by the evaporator or in the box or wherever that's at, if it's a case with doors or drawers, that sensor is going to be at that evaporator. All right, let's take it this. Now, this is a busy slide. I know it's a lot going on here, but I'm going to start out very slowly. So we're using 454Z as an example. It's walk-in coolers and freezers, all right? So starting with the y-axis, that's your charge in pounds. So the y-axis is going to be our vertical line here, and our x-axis is going to be the room volume, and that's based on cubic feet. So if you have enough charge or enough volume in the room, you may not need any type of mitigation strategy. So let's look at it, all right? A lot is going on here, but let's start with the y-axis and then the x-axis. And those. So if you're more charged outside, let's say this blue line, for example, all right, you're going to need, you're out of compliance. And what I mean by that is you're going to be, oops, my bad. You're going to need some kind of, you're out of compliance. And if you stop and think about this, sorry, I got held up there. If you stop and think about this with this charge size right here, this is a very small volume of area. There's nothing we can do about that. There's no mitigation strategy. So you have to take this in consideration when you're installing the equipment. Do we need to get bigger? Do we need to find a way to get less charge in there in that application? Okay, that's a tiny room. And the reason for that is it's out of compliance is because if you were to have a leak, okay, the refrigerant in that small volume, the risk is higher, which would be a major safety concern, all right? Now, in this triangle area here, we're going to see air circulation, not ventilation. So just in this area of this graph where this refrigerant and this volume lines up, it's a small volume, but it's a small charge. So if something goes off there, our mitigation strategy is going to be volume and air circulation. We're going to move the air around. We're not taking anything out. We just want it to get dissolved a little bit, okay? Move the concentration around so it's less possibility for flammability, all right? Now we move forward. Now under the yellow line here, if you will, air circulation and ventilation. So even though we have a lot of volume here, cubic feet, okay, we have a lot of charge. So that's going to call for 3 strategies. The volume of the room, which we've already got a large space there. We're going to circulate those evaporator coil fans, move that around, and we're going to bring in ventilation, either move air in or take air out and circulate that to get it up. That's the largest of the possibilities of the mitigation strategies, all right? Again, beyond this, you would be looking at smaller circuit sizes, which means your line size per charge, if you will, okay? And then last but not least, we're right here is just based on, here's our sweet spot. Anything in the yellow above this orange line is a perfect world, if you will. The volume alone of that room is the only mitigation strategy that you'll need. So the volume of that room, the cubic feet, is perfect for this charge size under this line. So right about that area there, when those line up, that is a good situation for you, okay? A2L sensors and safety shutoff valves is also required. The only thing we'll need there, that will be the only thing used in that yellow area, does not require ventilation or air circulation. It will be just have a sensor and the charges isolation valves.